Now we're going to talk about collisions and think about momentum and energy, in particular conservation of momentum and conservation of energy in a collision. Okay, so when we think about momentum, remember that momentum, we can sometimes refer to it as a letter P. Momentum is equal to the mass times velocity of an object. And when we think about collisions, we usually are mostly just thinking about conservation of kinetic energy. It's the conservation of really all the energies in the system. But if we're keeping things on a flat surface, it's just going to be conservation of kinetic energy. And remember, kinetic energy is 1/2 mv squared. Okay, so here we have a collision that's going to happen. We have 2 billiard balls, each of mass 0.4 kilograms. The first billiard ball is moving at 3.33 meters per second when it strikes another ball of the same mass, which is initially at rest. So V initial for our first mass is 3.33 meters per second. V initial of our second mass is 0. They're going to collide. We're going to experience conservation of momentum. And then the two balls are going to have different velocities after that collision, okay? And so after the collision, the first billiard ball is moving in the same direction with now a reduced speed of 0.56 meters per second in the same direction, okay? We need to find what is the velocity of my second ball after the collision. So V2 final equals question mark. And what is the kinetic energy lost in the system? Okay, we're going to find both of those. In the Canvas problems, one of the problems is going to ask you to solve for the pre-lab, the final velocity of a collision like this for the second ball. The other one is going to ask you to solve for the amount of kinetic energy that is lost in the system. So what we're going to do is just solve both of those in the same problem. So you only have to watch one video in order to get how to do both of those problems, okay? So after the collision, the first thing we need to do is apply conservation of momentum in order to figure out what is the velocity of my second ball after this collision. No matter what the collision is, you always conserve momentum. Momentum is always conserved, but energy is not always conserved. If energy is not conserved, it's an inelastic collision, okay? So we have to find, using conservation of momentum, the velocity of our second mass. So we've got to have the sum of all the momentums in our initial system must equal the sum of all the momentums in our final system. So it'll look like this. Remember, momentum is mass times velocity, so I'm going to say mass 1 times my initial velocity of mass 1 plus mass 2 times the initial velocity of mass 2 equals mass 1 times the final velocity of mass 1 plus mass 2 times the final velocity of mass 2. Okay, so that's what our equation looks like for conservation of energy. The sum of all the final momentum equals the sum of all the initial momentum. Okay, our second ball here is initially at rest, so we can cancel out that term already. And we're solving for the final velocity of our second ball after the collision. So we solve this equation for V2 final. So I'm going to move this term here to the other side. So we'll have M1 V1 initial minus M1 V1 final equals M2 V2 final. Now in this case, mass 1 is equal to mass 2. So all of these terms have a mass in them. Those masses are the same. So I can divide both sides by the same mass, which is 0.4 kilograms, and those masses will cancel out. Okay, so actually that makes our lives a whole lot easier. The final velocity of mass 2 is equal to just the initial velocity of mass 1 minus the final velocity of mass 1. So that's just equal to 3.33 meters per second minus 0.56 meters per second. So the final velocity of mass 2 is going to be 2.77 meters per second. Okay, so we found that part. Now we're going to see how much energy did we lose in this collision. If we didn't lose any energy, that's a perfectly elastic collision, but we have lost some energy and we're going to find out how much. So this kinetic energy that we lose is not the same thing as the change in kinetic energy. The kinetic energy lost is going to be the sum total of all your initial kinetic energies minus the sum total of all your final kinetic energies, okay? So let's think about what were all the initial kinetic energies in my system. We had 1/2 times the mass of the first ball times the velocity of the first ball initially squared, plus 1/2 times the mass of our second ball times its initial velocity squared, because kinetic energy is 1/2 mv squared. Our first ball had no speed, so that term is 0. So our initial kinetic energy is just 1/2 times our 0.4 kilogram mass times our initial velocity squared, 3.33 meters per second squared. And that equals 2.22 joules. Okay, our final kinetic energy is equal to 1/2 mass 1 times its final velocity squared plus 1/2 mass 2 times its final velocity squared. Okay, so that's equal to 1/2 0.4 kilograms times our final velocity for mass 1 squared, which was 0.56 meters per second squared. Yep. Plus our second mass times its final velocity squared, which we found up here. That's the 2.77 meters per second, square it. So our final kinetic energy of the system is 1.60 joules. So you see that we did, in the collision, lose some energy. How much? We subtract them. We take the sum of our initial kinetic energies, which was 2.22 joules, sum of the kinetic energies for both of those balls initially, minus the sum of the kinetic energy for both of those balls in their final state after the collision, and that's 1.60 joules. So the total energy that we lost in our system was 0.62 joules. Okay, so that's how you solve these final 2 problems for this week's pre-lab.